Imagine waking up in an oval, high-tech bed. You are completely naked and covered in medical electrodes.
Right, and you're being aggressively interrogated by this robotic medical arm.
Yeah, it's demanding to know what 2 + 2 is. But the most terrifying part isn't even the robot arm.
No, it's that you have absolutely no idea how to answer the basic questions of your own existence. You don't know your name.
You don't know where you are.
Exactly. And as you look around this room, you realize you don't know why the 2 other people in there with you have been dead for a very, very long time.
It is just the ultimate diagnostic nightmare. So our mission today for this deep dive into our source material, specifically the first 6 chapters of Andy Weir's survival log, Project Hail Mary, is to really explore this.
Yeah. What happens when absolutely everything is an unknown?
Right. Because this isn't just a science fiction summary. We're looking at a masterclass in using the scientific method as a literal survival tool.
Because before our amnesiac protagonist can even, think about why he's there, he has to save himself.
And that starts with figuring out where in the universe he actually is.
Which is a profound challenge when your own mind is a complete blank slate. I mean, he doesn't have a manual to consult.
No mission control in his ear telling him what to do.
Right. All he has is a laboratory he eventually stumbles into, a few basic supplies, and his own capacity for logical deduction.
Okay, let's unpack this. Because it really is like waking up in a cosmic escape room.
That's a great way to put it.
He slowly regains mobility, climbs a ladder, and finds this fully stocked scientific lab. But I want to push back on the actual physical reality of the ship for a second.
Oh, the gravity issue.
Yeah. When he wakes up, he notices his body is incredibly buff.
Yeah.
He's got these well-toned muscles, presumably from automated electrical stimulation during his coma.
Which is standard for deep space sci-fi, yeah.
Right, but he is struggling immensely just to stand up. Everything feels impossibly heavy, like he's wading through invisible molasses.
It's exhausting for him.
Exactly. So if humanity built this hyper-advanced spaceship, why wouldn't they just engineer it to have normal Earth-like 1G gravity? Why make it so heavy?
Well, that exact anomaly is what triggers his latent scientific instincts. He realizes things are falling way too fast.
Yeah, when he knocks something over, it hits the deck with a strange suddenness.
So he needs to establish a baseline.
Yeah.
He drops a high-density plastic test tube off a lab table and uses a brand new stopwatch to time the fall.
And it hits the floor in 0.348 seconds, which is incredibly fast.
Right.
But imagine you or him right now. You've just dropped this test tube, your heart is pounding, you're trying to do physics in your head, but you realize your own human biology is getting in the way.
The reaction time problem.
Yeah, he knows his reaction time, like the physical delay between his eyes seeing the tube hit the floor and his thumb clicking the stopwatch is going to completely ruin the math.
Because the event happens in 1/3 of a second.
Exactly. So what do you even do with that?
You engineer a better experiment, right? One that takes human error out of the equation.
Oh, the pendulum.
Yes. He takes a standard tape measure, ties it to a piece of nylon string, and hangs it from a hatch handle in the ceiling. He basically builds a makeshift pendulum.
I love this part because it requires understanding a really cool quirk of physics. It's like when you're on a playground swing.
Right, the period of the pendulum.
Yeah, think about it. Whether you're swinging super high and fast or you're just barely moving at the end of the ride, the rhythm, the time it takes to go back and forth feels exactly the same.
It does.
The only way to change that rhythm is to shorten the chains, or I guess go to a heavier planet. The width of the swing doesn't matter at all.
Though you are spot on. It is driven entirely by 2 variables, the length of the string and the localized force of gravity.
So he pulls the tape measure back, lets it swing.
He counts exactly 346 cycles in 10 minutes.
And doing the math on those cycles reveals the huge aha moment. The gravitational pull isn't Earth's standard 9.8 meters per second square.
No, it's 15.
Right. It's 1.5 Gs. He weighs 50% more than he should.
Which perfectly explains why his newly buff muscles are screaming in agony just from walking around.
But the deduction doesn't stop there, right?
No, because knowing the gravity is 1.5 Gs is one thing. Knowing how that gravity is being generated tells him what kind of ship he is on.
Because you can't just flip a switch and magically create gravity out of thin air.
Exactly. So he hypothesizes he might be inside a giant centrifuge, a spinning ring ship creating artificial gravity through rotational force.
So to test this, he repeats the exact same pendulum experiment downstairs in the dormitory.
Right, which is about 4.5 meters lower than the lab.
And this makes perfect sense if you think about spinning a bucket of water on a rope. The bottom of the bucket is traveling a wider circle and therefore moving faster than the handle near your hand.
And faster speed means more centrifugal force.
Exactly. So if he is in a spinning ship, the artificial gravity at the bottom floor should be noticeably heavier than at the top floor.
So he runs the 10-minute test down in the dorm, fully expecting a different number.
But he gets 346 cycles again.
Right. The force is mathematically identical. This completely rules out a centrifuge.
Which is mind-blowing.
It leaves only one physical explanation in the universe. The ship is experiencing constant, immense linear acceleration.
So the gravity he feels is actually just the floor of the ship pushing up against him as the entire vessel rockets forward at an unimaginable speed.
Yes. It's just a brilliant sequence of problem solving.
It really is. But as his brain recovers from the coma, the realization of where he is triggers these fragmented flashbacks.
Flashbacks of why he's there.
Exactly. The mystery suddenly shifts from his own personal amnesia to this apocalyptic threat back on Earth.
Because the physical stress of the gravity helps his memory piece itself together. He finally remembers his name.
Dr. Ryland Grace.
Right. A former molecular biologist who left the cutthroat world of academia to become a junior high science teacher.
But more pressingly, he remembers the Petrova problem.
Ah, yes. The Petrova problem.
Yeah, so a Russian astronomer discovered a faint infrared line arcing all the way from the sun to Venus.
And to visualize that, you really have to picture a literal glowing highway of heat bridging two planets across the solar system.
Right. And shortly after that discovery, probes revealed a horrifying truth. The sun's output is dimming exponentially.
It's losing luminosity fast.
Threatening an instant ice age, massive global crop failures, and, the starvation of the entire human race within 30 years.
And the culprit behind this dimming, a 10-micron wide alien cell living right on the surface of our sun.
They named it astrophage.
Which literally translates to star eater. It acts as an invasive species, breeding exponentially and siphoning off the sun's raw energy.
Okay, here's where it gets really interesting, because when you hear the phrase space algae, you probably think of some passive floating green scum.
Sure.
But astrophage is essentially a microscopic, warm-blooded rocket ship that runs on pure solar energy.
What's fascinating here is how it utterly defies everything humanity thought we knew about biology and physics.
It really does.
I mean, astrophage absorbs all electromagnetic radiation. It is completely black and opaque to X-rays, visible light, microwaves, everything.
Wow.
Furthermore, no matter what environment you subject it to, whether you drop it into liquid helium at absolute zero or throw it into a 1,000-degree industrial furnace, it maintains a constant internal temperature.
Of exactly 96.415 degrees Celsius.
Exactly.
Wait, let me stop you there. If this tiny biological cell is absorbing the raw, unfiltered energy of the sun or a high-powered laser, why doesn't it just vaporize?
That is the big question.
Right. How can a microscopic cell hold megajoules of heat without instantly melting?
Well, it utilizes mass conversion to survive.
Mass conversion.
Yeah, we are talking about pure E equals mc squared occurring inside a single-celled organism.
That is insane.
Dr. Grace's memories reveal an early experiment where his team hit a single astrophage cell with a weapons-grade laser.
Okay.
The cell consumed 1.5 megajoules of light energy. For context, that's enough energy to lift a 1-ton car about 500 feet into the air.
In a single microscopic cell.
Yes. And when they weighed the cell afterward, it was exactly 70 nanograms heavier.
Wait, so it literally turns heat energy into physical mass to store it safely.
It does. And when it needs to move, it turns that mass back into light. It emits a highly specific frequency of infrared light, 25.984 microns, to use as thrust.
It's the ultimate battery.
It really is.
But there's a massive personal irony for Dr. Grace buried in this biology, isn't there?
Oh, definitely.
Because he originally ruined his academic career by publishing a controversial paper mocking the scientific community.
For assuming life requires liquid water.
Right. He called the Goldilocks zone an idea for idiots. He threw away his entire life on this hill, was effectively exiled for professional science, and retreated to teaching middle school.
And then years later, he becomes the first human being to ever pierce an astrophage cell with a nanosyringe.
He analyzes the interior, only to discover that this sun-dwelling, radiation-proof, heat-converting alien rocket ship
is actually made of hydrogen and oxygen.
It is mostly water.
It's just the universe essentially laughing at his career-ending thesis. It is an incredibly humbling moment for him.
Oh, I bet.
But understanding the internal biology of astrophage was really just the first step. To have any hope of fighting it, Grace had to figure out its life cycle.
Right. Because if it's feeding on the sun and perfectly happy there, why is it creating that massive glowing infrared highway all the way to Venus?
Exactly. If you're a single-celled organism, you don't commute millions of miles through the deadly vacuum of space just for the scenery.
No, you definitely don't. So Grace sets up this ingenious little experiment in a dark closet.
He knows Venus has an incredibly dense atmosphere made mostly of carbon dioxide.
Right, so he builds a small box that emits the exact spectral signature of CO2.
Specifically light at 4.26 and 18.31 microns.
And when he turns the box on in pitch darkness, the astrophage immediately launch themselves at the light.
They respond to the specific spectral emissions of carbon dioxide as a navigational beacon.
So they use it to find Venus.
Right. See, astrophage hang out near the sun to absorb massive amounts of energy, but to reproduce, they need physical building blocks.
Like carbon and oxygen to build complex proteins, DNA, and cellular structures.
Exactly. And the sun is mostly just hydrogen and helium.
So they use their stored laser thrust to fly to the nearest rich source of CO2.
Which happens to be Venus. They harvest the carbon and oxygen from the atmosphere, breed through mitosis, and then both the parent and the new child cell fly all the way back to the sun to recharge.
So they migrate to breed, just like salmon swimming up a river, but on an interplanetary scale?
Exactly like that.
Now, discovering this was a monumental breakthrough for humanity. But it brings us to a character who is impossible to ignore in these SOS texts.
Oh, Eva Stratt.
Yes, Eva Stratt, someone who really drives the plot on Earth. She is a Dutch administrator who is granted absolute, unquestioned global authority by the United Nations to stop the astrophage apocalypse.
And we are talking complete immunity from all laws.
Total immunity. She operates entirely outside the bounds of normal morality, international law, or standard scientific protocol.
Her singular metric for every decision is the survival of the human race, and she will trample any right or regulation to achieve it.
I mean, she literally kidnaps Grace. She sends the FBI to grab him out of his classroom.
Right. She forces him into a sealed, argon-filled quarantine lab as a human guinea pig.
Just to make sure astrophage doesn't infect human biology.
Yeah.
And later on, she straight up commandeers a Chinese aircraft carrier, kicks the military off, and uses it as a mobile, explosion-proof breeding facility out in the middle of the ocean.
It paints a very vivid picture of a world where, faced with extinction, all the rules we take for granted have completely vanished.
It really illustrates the sheer, unadulterated desperation of a species facing a ticking clock.
It does. But consider what that actually implies for the plot. Stratt's extreme, ruthless methods, combined with Grace's discovery of how astrophage breeds on Venus, inadvertently provide humanity with its only lifeline.
Because by figuring out how to breed astrophage on an industrial scale,
and knowing how it converts mass directly into energy.
they suddenly had the perfect rocket fuel.
Exactly, which is a perfect bridge to understanding Grace's current situation.
Right. This infinite astrophage power source isn't just a fun biological quirk he remembers from a lab. It is the literal engine keeping him alive right now.
Those are the spin drives pushing his ship. The ship is powered by enriched astrophage.
And the engines consume just 6 grams of this cell mass every second.
Right. But because it's utilizing perfect E equals MC squared efficiency, converting that mass directly into energy, that 6 grams yields an unfathomable 540 trillion watts of power.
Let's put that in perspective for a second. 540 trillion watts is roughly equivalent to 30 times the total power consumption of the entire planet Earth.
All at once.
All the cities, all the cars, all the grids, multiply that by 30, and that is what is coming out of the back of Grace's ship every single second.
It's thrust on a scale that makes interstellar travel actually possible.
So armed with this recovered knowledge, Dr. Grace finally understands the mechanics of his vessel.
He accesses the control room and confirms what the ship's mission crest says. He is aboard the Hail Mary.
He checks the navigation screens and sees his velocity is over 11,872 kilometers per second.
But he is actively decelerating.
Right. And by tracking the sunspots on the star in front of him, he does some quick celestial math and realizes he is no longer in our solar system.
No, he is arriving at Tau Ceti.
Which brings up the obvious question, right? Why fly to Tau Ceti?
Well, amateur astronomers back on Earth had noticed that stars all across our local galactic neighborhood were dimming.
So astrophage wasn't just a local problem.
Not at all. It was spreading from star to star like a cosmic mold spore.
But Tau Ceti, which sits right in the middle of this infection zone, exactly 11.9 light years from Earth, was perfectly fine.
It was completely immune to astrophage.
So what does this all mean for Dr. Grace?
It means confronting the grim reality of his situation. I mean, he remembers looking at his middle school students back on Earth, these kids he cared so deeply about, and realizing they were going to starve to death in an apocalyptic ice age.
Yeah, he volunteered for this mission to find out why Tau Ceti was immune, hoping to send the cure back to save them.
But the horrific twist that his coma amnesia was protecting him from.
This is a suicide mission.
It's an absolute gut punch. He flew across the galaxy knowing he would never go home.
It is the cruel, inescapable math of interstellar travel.
Yeah, even using astrophagy as a miracle fuel, the energy requirements to move ship nearly 12 light years are just too vast.
There was barely enough fuel to get the Hail Mary to Tau Ceti in the first place.
There's absolutely no fuel for a return trip. Dr. Grace knew from the moment the ship launched from Earth that he would die in another solar system.
So his only job is to figure out why Tau Ceti is immune, collect that data, and send it back to Earth.
Right, he finds out the ship is equipped with 4 tiny, unmanned probes.
These little Bettel ships he lovingly named John, Paul, George, and Ringo.
Each one holds a 5-terabyte hard drive. Once he finds the answer, he's supposed to load the data onto the Beetles and fire them back home.
Hoping against hope that at least one survives the 12-year journey back.
The burden on his shoulders is unimaginable, and it's compounded by his absolute isolation.
Yeah, because the coma process that was medically necessary to survive the years-long journey was highly dangerous.
His 2 crewmates, Commander Yao and the Russian engineer Olesia Ilyakina, didn't survive the waking process.
It's a deeply moving moment in the text when he remembers who they were. He remembers Yao's stern, heroic leadership and Ilyakina's infectious, rebellious humor.
He painstakingly dresses their desiccated bodies in their mission uniforms, carries them to the airlock, and commends their bodies to the stars.
It's a really powerful transition from amnesiac to soul survivor.
He is now the only living human within a 12-light-year radius.
And the engines will cut off in 5 days, at which point the blinding infrared glare from the spin drives will cease, and he can finally use his sensors.
The Petrova scope.
Right, to search the Tau Ceti system for answers. It's such an incredible distillation of using the scientific method under the most extreme pressure imaginable.
It really is.
This deep dive shows that science isn't just a set of facts you memorize in a textbook. It is the ultimate survival tool.
Absolutely.
Whether you are dealing with an overwhelming project at work, or you find yourself waking up with amnesia in another solar system, the solution to sheer panic is establishing your baseline facts.
It's dropping a test tube to measure gravity.
It's building a pendulum out of a tape measure.
Or poking a deadly alien cell with a nanosyringe to see what happens.
You start with what you know and you build outward from there.
It raises a deeply philosophical question about what we value when everything else is stripped away. Dr. Grace is staring down his own mortality, millions of miles from anyone who even knows his name.
Sustained only by the hope that his scientific data might save a generation of children he will never see grow up.
Yeah.
And that leaves us with a lingering thought for you to explore on your own. Imagine you are Dr. Ryland Grace right now.
Stranded 12 light years from home.
Knowing you are going to die alone in the void, you hold the scientific data to save humanity, and you have 4 5-terabyte drives to send back.
What else goes on those drives?
Exactly. After the science is saved, what else would you upload onto those drives? What final message, what piece of yourself or of human culture would you send back to a world that has already aged decades without you?